All right, section 1.2 objectives. Number 1, solve linear equations in one variable. Number 2, solve linear equations containing fractions. Yeah. Number 3, solve rational equations with variables in the denominators. Number 4, recognize identities, conditional equations, and inconsistent equations. And then number 5, solve applied problems using mathematical models. I'll tell you this is the last one in a lot of the objectives that we're doing. I want to make sure you understand what that means right off the bat. Solve the word problems. Okay, it's going to give you word problems. You got to solve the word problems based on all the other objectives that we dealt with in that section. Does that make sense? Okay, so first things first, solve linear equations in one variable. I'm not going to do a lot of these because I really don't think I need to. If I do, however, please let me know. Okay, 2x plus 5 equals 9. What's our first step? I have several different options that I can do first, but someone said subtract 5, so I'm going to go with that. And then what? Divide by 2 on both sides. So x equals 2. And last thing, check it, right? 2 times 2 plus 5. Does 9 equal 9? Then that's the correct answer. You guys know how to do those, yes? Okay. What about this one? Because this one's the next objective. Because the next objective says solve linear equations containing fractions. See how these are fractions? So what should we do first? For sure we want to get rid of the fractions because we already don't like them, right? So if we can get rid of them, how do we go about getting rid of them? Get rid of the denominator? So what would okay, so there's two ways, right? I could just straight cross multiply right here, right? Because they're both just a single fraction equal to another single fraction. So would you rather do that? It doesn't matter. Okay, if I'm getting rid of the denominator by multiplying both sides by the common denominator, I'm multiplying both sides by 6. Otherwise, I'm just cross multiplying here. What do you want to do? Cross multiply? Okay, so if I cross multiply, I get 6 times 2x plus 5 equals 3 times 9. Distribute, distribute. 12x plus 30 equals 27. How is this any different from the first problem we just did? It's not. Okay, so subtract 30 from both sides. 12x equals -3. And now what? Divide by 12 on both sides. X equals negative. Simplifies, right? Both divisible by 3, so 1/4. This one's a little messier to check, isn't it? Still need to though, right? 2 times negative 1/4. So negative half. Negative half plus 5. 4.5. So 4.5 over 3 equals 9 over 6. How do we solve that? How do we know if that's true? You could cross multiply and figure out that way. How do you get from 6 to 3? Divide by 2, right? What if I divide 9 by 2? How do you get from 3 to 6? Multiply by 2. What's 4.5 times 2? So is this an equal fraction? So isn't that the solution? Yeah? Okay. So what happens if it's not just two fractions set equal to each other? What if it looks more like this? 4 over x excuse me, equals 5 over 2x plus 3. This is the one where we really do have to find a common denominator multiplied by that, right? Okay, so what would be a common denominator between x and 2x and 1? It's got to be part of, like, there has to be something. Whatever common denominator I decide on, each one of these denominators has to divide into it evenly, in fact. Excuse me. Does 2x divide evenly into 1? It doesn't. Okay, so it can't be 1. I know we call it the least common denominator, but is it ever the smallest number? No, it's at least the biggest number, if not bigger, isn't it? Okay? It's just the smallest number that they all divide evenly into. Okay? So hopefully you see that it's 2x. Okay? So if I if I multiply each term by 2x, what happens right here? The x's simplify and I'm left with 8. What happens right here? The 2's simplify and the x's simplify, right? So I'm just left with 5. And what happens here? 6x, right? I just multiply. It's exactly right. Now what? Subtract 5 from both sides. 3 equals 6x. Good. Dividing by both by 6 equals 1/2. Is it correct? Got to check. 4 divided by 1/2. Dividing by a half is multiplying by 2. So that is 8. Well, what's 2 times a half? Just 1, right? What's 5 divided by 1? How about if I write 5 instead of 1? And then plus 3. What's 5 plus 3? Does 8 equal 8? Then this is the correct answer. Now, sometimes it's going to ask you for the set of answers. Well, if it's the set of answers, what it wants is this. It just wants set notation. It wants these pretty braces. Just the answer inside the set notation. This is the set of all the answers that fulfills this equation. Does that make sense? Four over x plus 5 plus 2 over x minus 5 equals 32 over x squared minus 25. Again, several different fractions. 2 on this side, 1 on this side, so we can't just straight cross multiply, can we? Okay, so I want to try to eliminate the denominator if I can. So I have to find the least common denominator. Remember, it's not going to be the smallest one. It's going to be at least as big as the biggest one, if not bigger, correct? But it has to be a term or a number that every term there that divides into evenly. So I want you to remember that this is really what? We practiced factoring last week, right? So this is x plus 5 and x minus 5. So do you see how these kind of match up? So if I'm choosing the least common denominator, I'm going to end up choosing x plus 5, x minus 5. Do you see how everything in the denominator is going to cancel out? It may leave some stuff left over in the numerator, but everything's going to cancel out if I multiply each term by x plus 5, x minus 5. Does that make sense? So x plus 5 and x plus 5, what's left right here? 4 times x minus 5, right? What simplifies here? X minus 5's. What am I left? 2 times x plus 5. And then what happens over here? Cancel, 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 right? So I just have 32. Now this is just an Algebra 1 level problem, isn't it? Distribute, distribute. 4 times x is 4x. 4 times negative 5 is negative 20. Distribute, distribute. 2x plus 10 equals 32. When you combine your like terms, you get 4x and 2x, which is 6x. You have negative 20 and positive 10, which is negative 10 equals 32. When you add 10 to both sides, 6x equals 42. And when I divide both sides by 6, x equals 7. It's all right. It's all right. Is that the answer? You're positive? Oh, okay. 4 over 12 plus 2 over 2 equals 32 over 49 minus 25. 24. Okay? So this is really just 1, isn't it? And this is really 1/3. So this is really 1 1/3 equals 33. Can I change this number? I wrote down the wrong one. Thank you. 32. 32 over 24. These are both divisible by what? 8. So 4 over 3. Is 1 1/3 the same as 4 over 3? So guess what this is? The answer. How are you feeling about solving linear equations in one variable? And how are you feeling about solving linear equations containing fractions? How are you feeling about solving rational equations with variables in the denominator? Better than before I started? Okay. So number 4 is something you have never seen before. You've seen it actually a lot. We just didn't have to talk about definitions of these words. So can I show you what these definitions mean? Okay. We'll start with identity. Okay. An identity will look something like this. X plus 3 equals x plus 2 plus 1. Well, if I simplify this side, what do I get? X plus 3, right? Does x plus 3 equal x plus 3? That's the identity. It's just saying, look, they're the same. Okay? Conditional. Conditional is something like this. 2x plus 3 equals 17. 2x plus 3 equals 17 only if x equals what? Well, that's something we can figure out really easily by subtracting 3 from both sides and then dividing both sides by 2. Okay? 2x plus 3 will equal 17 if x equals 7. It's conditional on the fact that x equals 7. Right? And the last one is inconsistent. So it'll look something like this. X equals x plus 7. In what situation will x equal x plus 7? Well, if I try to solve it by subtracting x from both sides, 0 equals 7. Will 0 ever equal 7? Then this is inconsistent with what we're told, what we know. Does that make sense? Okay. Any questions about any of these? Look back over our objectives. Tell me if you have any questions about anything we've talked about today so far. You okay?